Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try these problems in your notes, and then unpause them to do them with me. Okay, does the graph or table represent a linear or non-linear function? And explain. So, first graph, is that a line? Yes, that is a line. So, this is linear. And the explanation? It's a line. It's a line, so it's linear. Okay, now the second graph. I pick this to do every year because, what do you think? What did you say when you did this problem on your own? Was it linear or was it non-linear? Now some students say, well, it's linear because this is a line and this is a line. There are no curves. And other students say, wait, it needs to be one line. And this is kind of like two lines put together. So, this is actually non-linear. The second graph is non-linear because it's not one line. It's kind of like we took a line and then we bent it, right? We took a line and then we bent it so that it has this it's still, has line pieces to it, but we want it to be one line. So, non-linear, and this isn't one straight line. So it needs to be one straight line in order to be linear. Okay, and lastly, remember from the table, we need to look at, on the top, 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. And on the bottom, I have minus 8. Yeah, 16 minus 8 is 8. 8 minus 4 is 4, and 4 minus 2 is 2. So actually, we're not subtracting the same number on the bottom. This is half. We're taking half of 16, half of 8, and half of 4. So we're like multiplying on the bottom. We're not even adding or subtracting, we're multiplying, and that's not okay. We need to be adding or subtracting the same number. We're going to talk more about what happens when you multiply the same number on the bottom. That's chapter 6. So we'll learn about that in chapter 6. But for now, we say this is non-linear because y does not subtract the same number. So y is not consistent in the numbers that we are subtracting. So non-linear has to be the same number. Okay, awesome. That was a little review from yesterday. Now let's go ahead and move on to section 3.3, function notation. Ooh. So now we're still talking about functions, but we're going to introduce function notation. Now this is very important. You're going to use this again in advanced algebra trig. If you go on to pre-calc, you're going to use this again. In fact, I teach this in pre-calc sometimes because students forget, so don't forget this. Okay, how can you use function notation to represent a function? We're going to talk about that today. Our learning target is that you know what function notation is and how to use it. What is function notation? How do I use it? And the success criteria is that you can use function notation to evaluate and interpret functions. Evaluate and interpret functions. We're going to talk more about what those words mean when we get to their respective examples. But first, we need to know what on earth is function notation? We keep talking about it. What is it? So, function notation is another name for y. You might have y equals 5x plus 2. We've seen that before. We've seen something like that before. But instead of writing y, we can write f of x. That's how we read this, is f of x equals 5x plus 2. So it's the same thing. We're just writing f of x instead of y, excuse me. So f parentheses with an x in the middle. And this is the value of f at x. We're going to talk more about what that means right here. So, you know that a linear function can be written in the form y equals mx plus b. We talked about that in the third example of our last video. By naming a linear function f, so I'm going to call this linear function f, you can also write the function using function notation. So f of x equals mx plus b. We're just changing the y to f of x. Now, if f is a function, so f is the name of some function, and x, which is the inputs in the domain, then f of x represents the output of f corresponding to the input x. So what that means is, remember, we would have our inputs, our x's, and we would have our outputs, our y's, and we would have, you know, some numbers, and they'd be pointing to numbers in the outputs. So what we're saying is, if I take f of -2, f of the input, that is the output. When you say f of 0, f of the input, that is your output. So f of x is like y, it's your output. But instead of just writing, you know, x equals -2, then y equals 3, we have a nicer way of writing this. We can say, when x is -2, when I put that in the function, then I get 3 as my output. So these are the same thing. X equals -2, y equals -3. But it's easier to write this way. If the input is -2, then the output, f of x, is 3. And if that didn't totally make sense to you, that's okay, because we're going to do several examples of things like this today. Also, one more quick note, you can use letters other than f to name a function. So we can have f of x, we can have g of x, we can have h of x, whatever you want. We can have p of x, we can have m of x. It doesn't matter. All the letter is it's the name of the function. So, doesn't matter. All right, now let's go ahead and move on to our very first example with function notation. Evaluating a function. So this was part of our success criteria. We needed to be able to evaluate a function. So, evaluate, if I'm evaluating something, if I'm evaluating this cup, I'm saying, I'm kind of rating it. How helpful is it? I'm saying things about the cup. I'm evaluating it. If someone is evaluating me as a teacher, they're looking about things or they're looking at things about me as a teacher. How do you teach? Is it effective? Things like that. When I evaluate a function, I'm saying, what happens when x is 2? What is the function when x is 2? What is the output when x is 2? So, we want to evaluate f of x when x equals 2 and x equals negative 2. So here's what we're going to do. If x is 2, then instead of writing x, I can write 2. F of 2 equals negative 4 times 2 plus 7. And I like to put parentheses around the x's. So, what we're saying is, what is the function when x is 2? So what you need to do is you need to put 2 inside the parentheses. We're taking f of 2. F when x equals 2. And that is equal to negative 4 times 2, because x is 2, plus 7. Now, you just need to figure out what this is. What is negative 4 times 2? Negative 8 plus 7. And what is negative 8 plus 7? Well, negative 1. So, what this means is f of 2 is negative 1. When x is 2, the output is negative 1. If the input is 2, the output is negative 1. And we just found the output. That's what it means to evaluate a function, is find the output when I'm given an input. And let's write that down. Evaluate, find the output given the input, or given this input. Given x equals 2, find the output. So now we've evaluated when x is equal to 2. We did that. Now, what about when x equals negative 2? So now we're going to take f of negative 2 equals negative 4 times negative 2 plus 7. We just rewrote f of x, but we changed all of the x's to negative 2's. So every x is now a negative 2. Okay. Negative 4 times negative 2 is positive 8. Plus 7. And 8 plus 7 is 15. So, when the input is negative 2, the output is 15. And there you have it. F of negative 2 equals 15. We have evaluated. Let's check and see if we were correct. When x equals 2, f of x equals negative 1. When x equals negative 2, f of x equals 15. Wonderful! They did exactly what we did. So, we were correct. All right. Example 2, interpreting function notation. So in this example, you're going to see why we use function notation. Why is it helpful to use these f of 3 instead of just saying like y when? Like y equals, whatever when x equals 3. Why is this notation so helpful? We're going to see in this example. when we have like real world applications, and that's why we do math, right? There are so many real world applications. Using function notation can be easier to understand than when we use y. So let f of t, so f is the name of a function, and t is the number of hours. Okay, so the function f of t is the temperature in Fahrenheit. Temperature in Fahrenheit. T is time in hours. So what we're saying is f of t is how hot or cold it is. And t is the amount of time, the number of hours. So this function, f of t, it intakes hours, the input is the number of hours, and the output is the temperature. Remember, we talked about functions as a box that takes an input and spits out an output. We're taking the input of hours and we're outputting temperature. So let f of t be the outside temperature. So we're focusing on the temperature outside of our apartment or outside of our house. So t hours after 6 a.m. So hours after 6 a.m. Okay, explain the meaning of each statement. Okay, what does each statement mean? So we're taking the number of hours after 6 a.m. and we're spitting out temperature. Okay, I'm going to erase this. Hopefully this was in your notes. Put that in your notes if it's not. Pause the video, put that in your notes. Because that's the most important part that's going to help us with this question. So, f of 0 equals 58. So, this is saying that the input is 0. The input is 0 hours after 6 a.m. If it's 0 hours after 6 a.m., what time is it? It's 6 a.m., right? 0 hours after 6 a.m., it is 6 a.m. So we're saying at 6 a.m., what? F of 0 equals 58. So the output is 58. Now, what was the output? Oh, the output is temperature. So what this means, f of 0 equals 58, this means at 6 a.m., it's 58 degrees Fahrenheit outside. And that's your final answer. At 6 a.m., it is 58 degrees Fahrenheit outside. Okay. Now, let's look at part B. F of 6 equals n. Okay? So remember, when you see letters in math, it's a number. When you see n, you see x, you see y, whatever it is that you see, it is a number. We just don't know what number it is. It's some number n. And that's why we use letters. Because if I used a number, well, it's not 3. You know, we don't know what number it is. So I can't write a number. I have to write a letter. That's why we use letters in math. Okay, So, f of 6. The input is 6. So, we're talking 6 hours after 6 a.m. What time is it if we're 6 hours after 8 a.m.? Let's see. 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m. 12 p.m. So it's noon. 6 hours after 6 a.m., it's noon. So at 12 p.m. or noon, whatever you want to call it. That's why we call it afternoon, because if it's 3 p.m., it is afternoon. It's after 12 p.m. Okay, but at noon, the temperature is N. Our output is N. Is N degrees Fahrenheit. Now you might think, well, that's stupid. Why would we even think about this? Why would we think of f of x equals N? I want numbers. I don't care if it's N degrees Fahrenheit. I want a temperature. Is it 60 degrees? What is it? Well, sometimes we don't know, right? What if it's 6 a.m. right now and we're trying to think about what will the temperature be at noon? We don't know. We don't know what the temperature will be at noon, but we'll find out. If I want to write a program that maybe it turns my heat on when it gets below 50 degrees, although you probably want to turn your heat on before that, but maybe I want to be warm when it's less than 50 degrees outside. So I needed to tell the program, if we get less than 50 degrees, turn my heat on. But the program doesn't know what the temperature is outside yet. It has to take the temperature. So we're just going to say the temperature is N. Until we figure out what the temperature is, let's call it N. So there are some more potential applications for you. Okay. And that is that part all done. The input is 6. The output is N. So when it is 6 hours after 6 a.m., which is 12 p.m., when it is 12 p.m., the temperature, the output, is N degrees Fahrenheit. All right. Now, lastly, we don't even have any equal signs. We just have f of 3 is less than f of 9. What does f of 3 mean? Well, f of 3 means the temperature, the temperature 3 hours after 6 a.m. And what does f of 9 mean? It means the temperature 9 hours after 6 a.m. Let's see. So 3 hours after 6 a.m. is 9 a.m. So the temp at 9 a.m. is less than, here, I'll just put the mathematical symbol, is less than the temperature at, what is 9 hours after 6 a.m.? 7, 8, 9, 10, 11, 12, noon, 1, 2, 3 p.m. 3 p.m. So the temperature at 9 a.m. is less than the temperature at 3 p.m. So what this means, f of 3 is less than f of 9, is it's colder. It's colder at 9 a.m. than it is at 3 p.m. That's what f of 3 is less than f of 9 means in this context, right? In the next example, f of t could be something completely different. It could be the height that a ball is off the ground when I throw it. You know, it could be so many different things. In this example, f of t was the outside temperature. In another example, f of t could be something completely different. How much money we make, depending upon how many t-shirts we sell. Something like that. Okay. Alrighty. So, this is one of the more important pieces about function notation. This example is why we use function notation, is so that we can more easily make meaning out of these functions. Why do we care about functions? Why are we learning about functions? It's because we can do things like this. We can talk about problems like this, where 0 hours after a certain time, this is the temperature, and so on and so forth. We're looking at relationships between inputs and outputs. And it is the foundations of algebra, really. Okay, let's check and make sure that we are correct. The temperature at 6 a.m. is 58 degrees. When the temperature, the temperature at noon is n degrees Fahrenheit. And the temperature at 9 a.m. is less than the temperature at 3 p.m. Perfect. Awesome. We were right. Okay. That is all I have for you today. We're going to continue our work with 3.3 in the next video. What I'd like you to do right now is assess. Assess your understanding on a scale of 1, 2, or 3, where 1 is, I don't know anything, I don't understand anything. 2 is, I think, maybe I got it. And 3 is, oh my goodness, this felt wonderful, this felt fantastic. Where are you on this scale? And remember, you don't need to be a 3. Goodness, in college, I sat in between a 1 and a 2 all the time. So, it's not bad if you're a 1. There's nothing wrong with being a 1. It just means that you need to go get help from the teacher, which is what I did every day in college. I was basically a 1 all throughout college. Doesn't make you less smart if you're a 1. It just means you need a little more help. And that's okay. That is totally okay. So, rate yourself, your understanding of the learning target and the success criteria. Hopefully you wrote that down at the beginning of the lesson, like we always do. So, go back and look at the learning target and success criteria and think, do you not understand it? Do you kind of understand it? Or do you completely understand it? Where are you at? And ask questions if you need to. All right. Here are some practice problems that you can do to practice the skills that we have learned in this video. But of course, remember to do the homework that your teacher assigns as well. All right. And as always, let's end our video with a launch. Today's launch comes from Malala Yousafzai. Oh gosh, I probably butchered that name. I'm so sorry to that person. But they have a wonderful, wonderful quote that says, "Let us make our future now, and let us make our dreams tomorrow's reality." Let's think about what that means. Let us make our future now. But wait a minute, the future is the future. How could it be now? Well, I think what Malala means with this is all the things that you say you want out of the future. You want a family. You want a successful business. You want to write a book. You want to have really nice muscles. Whatever you want. Make that now. If you're like, someday I want nice muscles, someday I want to be able to lift 100 pounds, if you don't start working on that now, it won't be in your future. If you never work out, you're like, in the future, I want muscles. If you don't work out right now, you're not going to have muscles in the future. If you want to have a book that you have written in the future, it's not going to happen if you don't write the book. So make your future now. Write the book now. Work out now. Anything you want. You want a small business? Or you want a big business? You want a business? You can start working on that now. Research. Do I need to go to school for this? What do I need to learn for this? Job shadow a business person, ask questions, read articles. Whatever you want from your future, you want a family. Start dating, learn what you like, read books about how to have a successful relationship, learn more about parenting, spend more time around kids. Whatever you want in the future, start working on it now, because it's not going to be in your future if you don't work on it now. And let us make our dreams tomorrow's reality. So these go hand in hand. If you want your dreams to be there in the future, you need to work on it now. What are your dreams? Do you even know what they are yet? I mean, and your dreams can change, that's fine. Goodness, when I was in high school, my dream was to study narwhals. It's not a dream of mine anymore. But I also had a dream in high school of being on Broadway. That's still a dream of mine. And you know what? Maybe I'll do some theater when the coronavirus is all done and over with. But what are your dreams? Name them. Know what your dreams are, because that makes them easier to achieve. It makes it easier to start working on them now. So, whatever you want in the future, whatever your dreams are, start working on them now so that you can have them in the future. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks so much for being here. Thanks for watching. Bye.